Hi all, welcome back to our YouTube channel. We hope you all are doing well and preparing well for your FRM exam. Topic that we have today is from FRM level 1. It's from paper 2, that is quantitative analysis, and it is from topic conditional probability. But given its application in bond portfolio, you can think of this as a binomial distribution as well. We'll see how that comes up with. And yes, please do subscribe to our channel, like, comment, and share with your friends who are preparing for similar type of exam. And yes, our goal is to stimulate your thought process to enhance your learning so that you are in a position to apply concepts, because FRM is a application based exam. If you just know the concepts, but if you are not in a position to apply, then it's become a bit difficult to crack exam like FRM. So this is a question that we would be covering today. So there are three bonds in the portfolio, and each single bond has a probability of default as 10%. So you have been given 10% probability of default. Defaults are independent. And what we have been asked is, portfolio managers gives you some additional information that at least two of the bonds have defaulted. What is the probability that third bond also will default? So just as an notation point of view, if there are three bonds, if you know that two have defaulted, what is the probability that third one will also default? So if I were to write what is the probability of third getting defaulted, given you know two bonds have already defaulted. So this is something that we are interested in. Okay, let's see how we do it. So this is a very basic method in even if you don't know conditional probability, you just know that these are independent bonds. So the defaults are independent, that so that joint probability would be just a multiplication. So just consider that these three bonds that we talked about, and we would calculate the corresponding probability over here. So let me write same heading over here. So now what we'll do, we'll just list down what are the possible outcomes for the given situation. So what may happen that your all three may default. Okay, last possibility would be your all may survive. Okay, so in between there are various possibilities. Say, I mean, from your truth tables learned in your high school, you can just write DDD, and as very simple way to write this. And for bond B, it's DDSS. There are various possibilities, but yeah, this is a simplest way you can write all the possible outcomes. Over here, it would be DSTS, and again DS over here default. So all three defaulting, all three surviving, AB defaulting, C surviving, likewise all the possible outcomes. So let's see, we were given the default probability is 10%. So the probability is 10% here, 10% here. So likewise, what I'll do, wherever it is D, I will put 10%. Wherever it is S, I'll put 90%. So over here, it's 90%. And so I'll just write 10, 10, 10. 0.9, 0.9, just replacing my S with this thing. So over here, like it would be 0.1 again, 0.9, 0.9, 0.1, 0.1. Again, survival is 0.9. And over here, it would be like 0.9, 0.1, 0.9. You can just do a practice. It is just a truth table thing that I'm using over here. So now we have jotted down all the possibilities, their corresponding probabilities. Now what we'll do, we'll calculate what is the probability of this outcome, that all three defaults. So what's the probability? So probability, so over here it's 10% times 10.1 cube. So it would be 1 over 1000. That is your 0.001, or you can say it's 0.1%. So both are correct. And at the bottom, I would say it is 9 cube. So we'll do 9 cube in Kelsey. So it's 729 divided by 1000. So it's divided by 1000. So 0.9 into 0.9. Yeah, so it would be 0.729 or 72.9%. Okay, so these are the two possible outcomes. Likewise, if we calculate 0.1 into 0.1 into 0.9, that would give you 0.009. So, or you can just write it as 0.9%. So over here also it's like 10%, twice 10%. So it is twice 10% once. So it would be same thing. Okay, like, and this we have to, or let me just write wherever there are two 10% and one 90%. Let me just quickly write that because the multiplication will not change. This we will calculate like with this, and yeah. So like 3 times we had 0.9%, we will have something similar for these three blocks, wherein we have 0.9 squared into 0.1. It's 0.081. That is your 8.1%. In a similar way, it is 0.0081. That is 8.1%. 0.8%. Okay, so let's see if we are getting total as 100%. So what I'll do, I will multiply 8.1 into 3. It is coming as 16.2. So these three, this one, this one, this one, it's just a validation. It's 16.2, 72.9 we have already here, and 0.9% into 3. So 0.9 into 3, that is 2.7%. So 2.7 plus 72.9 plus 16.2. And I think something is missing. So 0.1. I think over here it would be 8.1 into 3. So it would be 24.3. Just let me just correct it because it was not coming as 100. Let me just write for the sake of simplicity and just to give you a sense of binomial distribution also. Let me just write that probability that your 3 bonds default is 0.1%. Probability that your 2 bonds default. So 2 bonds default, as in we have to consider this probability 0.9, 0.9, 0.9. That would be 2.7%. And probability that your 1 bond defaults and 2 survive. These are these 3 cases. 8.1, 8.1, 8.1. That would be equal to 24.3%. So this is in fact kind of a distribution. You can calculate same using the binomial distribution. I'll tell you in a while how. But yeah, I mean, see, what we have been asked is very simple to calculate. These are just for your learning perspective. Probability that zero bonds will default is 72.9. Now it should come to 100. Let's see. So 0.1 plus 2.7 plus 24.3 plus 72.9. It's 100. So it is coming as 100. In fact, I'll just show you beautiful distribution of this. But yeah, if you were to calculate in a short, you can calculate using this probability of getting 3 defaults. So it's 3C3. Probability of 1 default is 10%. So you're looking for 3 defaults and 0 survival. You should ideally get 0.1%. Likewise, for x equal to 2, you 2 bonds chosen out of 3. So 0.1, 2 bonds defaulting. So default probability is 10%, 2 bond defaulting, 1 surviving. You should get 2.7. It's homework. You can do this. X equal to 3, x equal to 1, 3C1, 0.1 to the power 1 defaulting, 2 surviving, 0.9 to the power 2. Probability of no defaults. So 3C0, 0.1 to the power 0 because no defaults, all surviving, 0.9 to the power 3. You should ideally get 72. So these are the two methods. This was just a demonstration of binomial distribution. This has nothing to do with your calculation. What I was interested with, what we were interested in, what we were asked is probability of, say, A defaulting given you know B or C has already defaulted. So this is a case wherein you know that either of this has defaulted and third also defaults. So in your numerator, it's 0.1%. It's just a one outcome that we are in, possible favorable outcome that you're interested in. The probability of that is 0.1%. And like in denominator, what you have all the possibilities wherein first two bonds have defaulted. So these are the two possibilities, the first and second, wherein the first two bonds have defaulted. So what is the probability of these two? 0.1% plus 0.9%. So 0.1% plus 0.9%. So you can just see it's 0.1% divided by 0.9 plus 0.1%. That is 1%. If I just divide this by 100, multiply with top, it would be 10%. So probability of third defaulting given either of it has defaulted is 10%. So from our question, the answer is B. So it may appear a very big problem, but if you know very basic things, it might be. So that's why I have tagged this as a basic method. Even if you don't know about, just know about formula of conditional probability, or you know that the outcome that you're looking for and total outcomes. So total outcomes that we are looking for, wherein first two bonds have defaulted, and the favorable outcome, that knowing that first two bonds have defaulted, third also defaults. So that was only one. So this is how you calculate. We have more to it. Just stay with us for next few minutes. I'll show you the beautiful distribution of these things. And yes, if you want us to take these kind of questions in one-on-one tutoring, our institute has come up with a plan wherein you can come up with 10 questions of your choice, any questions of your choice, and those will be addressed in one-on-one tutoring like this. And definitely it's assured that you will get your fundamentals strong, and you will have a better ability to apply concepts. And yes, in fact, there would be more Excel workings and other stuffs that would be shared in this plan. And yes, we have very experienced faculties from industry. And of course, definitely you will feel that now you're becoming result oriented once you offer this kind of tutoring. So coming back, the second method is like if you don't want to plot all the possibilities and everything. So this was a formula for conditional probability. So let's see how method 2 says. So in this case, what I'll do, I'll just replace this B with B or C, because we know that at least one of them, so B or C will calculate. So let me just put in. So probability of A this equal to probability of A and B union C. I'm just replacing B by B union C because it's also a B is also set. There could be a set which is a union of two sets. So that's perfectly fine. In denominator, it's union of two sets again. Now be very careful. Now I'll just open this bracket. What I'll do, I'll just open A and B union A and C. Like how you multiply A with B plus C, it's like A into B plus A into C. In a similar way, we can do this operation for sets A and B union probability of A intersection C over probability of B union C. Okay. Now, most important, for earlier method, you did not have any tricky part, but if you're using this method, there is a small trick. So try to understand pictorially what you're trying to calculate. So you're trying to calculate B probability of A and B. So this is something that you are interested in first. Okay, let me use another color now. If at all we have, yeah. And the another option is probability of A and C. So this is a portion that you're interested in. Okay, so but when we add these up, this portion is getting added twice. So that's where the catch is. You need to subtract this when you are calculating the numerator part. Okay, so what we'll do, we'll calculate probability of A and B because we know that these are joint independent events, defaults are independent. So the probability would be just 0.1 into 0.1. Same case for B, A, and C, 0.1 into 0.1. But you have to subtract probability of all three defaulting, which was how much? It was 0.1%. So it was 0.1%. Okay, so that we will subtract. In a similar way, it's a very common thing. Probability of B union C is probability of B plus probability of C minus probability of A and B. Okay, so if I calculate this, how much it would be? 0.1 into 0.1 times, let me just do it for you. Or rather, I would do 0.1 square into 2. That would be an easier one. So 0.02, first two components are 0.02 minus 0.001. And in denominator, it's 0.1 plus 0.1, that is 20%, and probability of A and B again. So it's, let me just write it for you, 10% plus 10% minus 0.01. So in denominator, we have 2% minus 0.1%. So 2% minus 0.1% would be 1.9%. In denominator, it's like 20% minus 1%, it would be 19%. Over here also we got 10%. So the probability that we are interested in is 10%. Now let me show you something very interesting. Just give me a moment. So if you recollect what we had calculated in above slides was this distribution. So over here also this is plotted on Excel. So probability of getting zero defaults is 72.9%. Probability of getting one default is 24.3%. Likewise for 2 and 3. If you notice that getting all three defaults is 0.1%. So this is a binomial distribution. You can say probability distribution. It was for 3 bonds. It can be for more bonds also. So in this way, you can get a sense of the data that you're dealing with. It can be anything in finance. So it's because bonds, we are considering it either default or survival. There could be other distributions also, but yeah, the fundamental idea will remain same. Of course, the formula may differ if it's normal distribution or Bernoulli, Poisson, any other distribution. Yes, please do subscribe to our channel, like, share, and share with your friends. And please do uh, think on this plan. This can be very useful because reading concepts again and again may not be that helpful. Interaction, discussion on the concepts, applying concepts are something which are very much needed for exams like competitive exams like FRM. Hope you like the video. If yes, please do share with your friends and stay connected with channel. Thank you.